Hey, everybody, let's go ahead and get started on this homework for 6.2.1. We're in the second part of the chapter for chapter 6, right? Fanny Toomer. What a silly name, huh? Who made up that? Nobody. That was actually the name of my third grade teacher. She was my favorite teacher ever. I think we got her. She was like her first or second year teaching, and she was just awesome. La Tercera Elementary in Petaluma, Miss Fanny Toomer. She should be famous. She's the best ever. Anyway, don't forget the easiest 3 points: your first and last name, the date, okay, your teacher's name, and the period. Your teacher teaches more than one period of math. And fourth quarter, you have to have what we're doing here, right? CPM 6.2.1, and I'm going to go ahead and put the problem numbers there. We're doing 6-69 all the way through 6-78. Let's make sure there's nothing on that next page. Good. 6-78. Okay. All right. How do we do this? 6-69, it wants us to look and see if these two expressions are equivalent. How can we tell that? Well, there's more than one way. One is you could put a number in for x, figure out what each one equals. If they're equivalent, they'll equal the same thing. But another way is to simplify. Okay, simplify, or what we call distribute. If there's a number outside parentheses, there's nothing in between. I'm supposed to multiply that by each thing. This isn't 3 times 4x minus 2. This is 3 times 4x minus 3 times 2. Okay, so you can go ahead and do that. And I do want to let you know that warm up for today, 3 times 4x minus 2 looks a little familiar. Okay, that will be a common theme today. Okay, all right. So check that out and see if you end up with the same type of problem, or go substitute. All right, if the area is 1/6 and the width is 1.5, or 1 1/2, or 3/2, then I'm looking to see 3/2 times what ends up being 1/6. Okay, now 1/6, since there's a 3 on top there, I'm going to see if I can simplify this or get a equivalent fraction. 3 times 3 and 3 times 6. 1/6 is the same as 3/18. So maybe I can have a number here. 3 times what is 3, and 2 times what is 18? I don't know. Check that out. That's what we're going to solve, right? See if you can figure that out. And when you get done, don't forget the second part. Now they want the perimeter. Once you get that, I have to add this plus the 3/2, or add this plus 1 1/2, plus this again, and plus 1 1/2 again, right? Okay. The area of these two trapezoids. Remember, the area is the average of the top and the bottom. That's the top plus the bottom divided by 2 times the height. Now, why the average? Well, because if I did the top times the height, it would be like this small rectangle inside. Not big enough because it's not including this triangle or this triangle. And if I did the bottom times the height, well, that would be exactly the same as this rectangle, right? This times the height. Well, that's including all this and all this. So that's too big. What do I want? I want something right in the middle, it turns out. So right in the middle between 4 and 13 is 4 plus 13 divided by 2. That's how you get the middle of two numbers. Multiply that by the height, and you get the answer. Okay? And again, I told you it'd be like a theme. You might recognize 4, 13, 16, 21, 4, 13. Aha, we did this in the warm-up. Go find your paper. Same idea here. Okay? Now, what kind of problems are on 672 when they want you to simplify each expression? Well, they want you to find the answer. But the deal is I have subtracting, I have multiplying, I have parentheses. Here I have multiplying, I have exponents, I have subtracting, I have all these problems or what we call OOO problems. OOO, I know the answer. Order of operations. Make sure you follow the order of operations, right? Remember, parentheses comes first. They can be the fancy ones. They can be the big blocks. That always comes first. Then it's exponents, and what's called square roots, right? Exponents. Now, then we're going to divide and multiply, or multiply and divide, whichever one comes first. We're going from left to right. And last, we're doing the adding and subtracting, or subtracting and adding from left to right. What does from left to right mean? That means you have subtracting and adding. Whichever one lined up first goes first. Okay, but make sure you do that last after all the multiplying and dividing. So here I have subtracting, I multiply, I have parentheses. I'm going to do the parentheses first. 3 minus 1. And then I'm going 5 times that, right? All right, because I'm going to multiply before I subtract. Okay, and then I'm going to get the subtracting last. Okay, this one I'm going 4 times 31 and 3/4. Don't go do 4 times 31 and forget to do the 3/4. Okay, this was a generic rectangle. You got 31 and 3/4. 4 times 31 is 4 30s and 4 1s, 120 and 4, 124. 4 times 3/4 is 12/4. Simplify that and add them. Okay, same idea here. This is going to be a 6 times 18 and 5 6. 6 18s is almost 6 20s, which is 120, minus 6 2s is 12. 120 minus 12 is 108. Or 6 10s is 60, 6 8s is 48, 60 and 48, 108. And now I go 6 times 5 over 6 is 6 times 5 is 30 over 6. Simplify and add. Okay, I'm giving you partway there. You got to finish up. I got to do the exponent first here. 2 to the second power is 4. What am I doing to the 4? I'm multiplying it by 3.45. Okay, and here, how hard is multiplying something by 1? All right, 1 times. So once I get the answer here, I'm going to subtract 8 and 18 hundredths. Okay, what am I doing first here? The parentheses. This makes this 1. Then I do exponents. This makes this 4. So I have 3 times 1 and 4 times 5 minus 4 plus 3 times 1. Do the multiplying, this and this, before I subtract or add. That's the last thing I do. Okay, you go try that. On 673, I almost forgot that one. I had to draw a number line and place all of these on the number line. -5.5. This is -1, -2, -3, -4, -5. Now don't go to the right when you go 5.5. 5.5 is halfway between 5 and 6. So this is where -5.5 goes. Okay, that's a common mistake. People go over to that -5, then they move to the right to get to the half. Well, that's -4.5 in between 4 and 5, right? Okay, where are you going to place the other numbers? I think you can find -2, you can find 4 3/4 and 6, -1. 3 halves, go ahead and change that to a mixed number, and -0.5. I'm going to let you put the rest of the numbers there. I think you can do that, and you just come back and check your answers, okay? Okay, 6-74. Now they're trying to get me to check these two expressions and see if they're equivalent. It's the same type of problem. Okay, so I need to distribute this 6 times 4x minus, 3 times 4x minus 3 times 2, and then add 8. Now check this out, because this was 3 times 4x minus 2. This is 3 times 4x minus 2 plus 8. Once you've done that work, go use it again down here and then add the 8. Okay, the next one, 2 times 6x plus 1. I got to go 2 times 6x plus, not plus 1, plus 2 times 1. Okay. All right. All right. And again, the theme continues. These might look familiar to you. okay, along with the next ones. Evaluate for the value given, 6h minus 4, 8r plus h, r squared, 6h minus 4, 8r plus h, r squared, r equals 3, h equals 5, r equals 3. We did this. Go get your warm-up paper. Well, tell me you didn't do the warm-up. I know you're better than that. All right, so 6-75, I'm going to write those problems down real quick. And then you are going to check your warm-up for answers or go do your warm-up real quick. Get those points, right? They're ed puzzles now, right? Okay, and then come back and check your answers. Okay, 6-76, what are we doing on that one? Each of the following parts, write the complete set of fractions on your paper. Okay, so we're going to complete these fractions to make them close to 0. Okay, and I want something over 16, and I want it to be close to 0. I want something over 10. I want it to be close to 0. I want 4 over something to be close to 0, and 10 over something to be close to 0. What am I going to put in these numbers? Right? Well, close to 0, it's 16 pieces. I want the small piece, right? So I want a small number on top. If I want this to be close to 0 and I'm getting 4 pieces, I want those pieces to be tiny. So I want a big number on the bottom. Same thing here. Okay. On B, I want to rewrite these with the denominator or numerator. I want it to be close to a half now. So what over 15 is going to be close to a half? What number over 9 will be close to a half? And 4 over what number will be close to a half? And 10 over what number will be close to a half? Okay. And the last ones, now I want to make them greater than 1, but less than 2. Bigger than 1, less than 2. 6 over what will be more than 1, but smaller than 2. 10 over what will be more than 1, smaller than 2. And what number over 6 will be more than 1, but smaller than 2. And what number over 3 will be more than 1, smaller than 2. Play with it. Yeah. Right. What if there's a 10 here? Is that close to 0? No. Okay. What if there's a 10 here? Right. Is that close to a half? Not too bad. You can get closer though, huh? Okay. So play with those. Those are fun puzzle type problems. Now we got 2 left, 6-77. Include a sketch and division number sentence to support your answers below. How many fifths are in one whole? Okay, so I'm going to have one whole. And there's my fifths, right? Five fifths equals one whole. Okay, how many fifths? Now, what's my division problem? One whole divided by 1/5 equals how many? Well, you see them there. Okay. You're going to do the same idea, but now you're going 2 1/3. 1, 2. All right. And I'm going to divide this into thirds. How many thirds is that? You can also do pizzas if you want to do pizzas, right? You want to do pizzas for the next one. How many 2/5 are in 4? Okay, well, I got 1, 2, 3, 4, and each of these are going to be cut into 5 pieces. Okay. Fifths aren't the easiest ones to cut. Wish they would add fourths on this one, right? So you can do how many fifths are in how many sets of 2/5 are in 4, right? That's a little bit tougher, but you can do it. Okay, that's how I would set it up. But again, you can use pizzas, you can use number lines, your choice. Okay. All right. What portion of a dollar is represented by the following? Okay, 1/4 is 25 cents. 25. How many cents are $1? So 25 over how much? 100, right? Okay. So let's go ahead and write that. 3 dimes is how much money? A dime is 10 cents. So 3 times 10 over how much, right? 8 nickels. Okay, how about D, 23 pennies? 23 cents, right? 5 quarters. That is a little bit tricky. And 9 dimes. I think that you can try these. I don't think I want to give you too much more of a hint, but this, how many quarters is $1? 4, right? So that's going to be more than $1. More, your fraction should be more than 1. All right, good luck on the rest. Again, go see your teacher if you need help.